Okay, welcome back. This time in the Physics 1108 labs, we're going to actually measure how much the temperature of water changes when we add hot materials to it, and use that to calculate something called the specific heat of a material. The specific heat varies from material to material. What it tells you is how much energy it takes to change the temperature of the material. So as you add heat to some object, its temperature changes. The specific heat tells you how much the temperature will change for adding the same amount of heat. Now, to measure what the specific heat is, we're going to use 3 different samples of material, plus one that you find on your own. The 3 that are in your kit are steel. You should have a big roll of steel wire. I cut mine down substantially so it would fit in the experiment pot here. There's also a roll of aluminum wire, 25 feet of it, and there is a roll of copper wire. Now, this roll of copper wire is labeled bare copper wire. It's the thicker of the 2 kinds of copper wire, and this is the one you want for this experiment. Okay, the first thing to do, I'm just going to do one of these in this video, is to measure the mass of the sample. Now, we have a spring scale here. It's good enough to measure a cut down sample of the steel or to measure all of the aluminum, but it's not strong enough to measure all of the copper. So with the copper, you just have to use the label which says 4 ounces. It is strong enough to measure the entire weight of the aluminum. So we're going to do that one. We hook the hook in here, and you can see that the mass is about 40 grams. So we remember that, write it in the spreadsheet, 40 grams for the mass of the sample. To measure how much the temperature of the water changes, the first thing to do is to do the prepared watered sample like in the other video. I have one here that I did earlier, and it's sitting here with the thermometer in it in the testing thermos. Now we have to heat up the aluminum. So we put that in a coffee cup. Notice I've made a convenient little handle. Put it in the coffee cup. You can include the plastic spool, that won't hurt anything. And we add in some boiling hot water. This water was boiling a few seconds ago. Put that in over the top of the aluminum sample and let it sit for a little bit until the aluminum is all at the same temperature of 100 degrees Celsius. Once that's done, we're going to take it out of the hot water, put it in the cold water, and measure the temperature every 30 seconds for a couple of minutes. So at this point, it's a good idea to make sure your thermometer is actually on and flipped over to Celsius. It turns off if you leave it alone too long. Okay, that's been almost a minute in here. I assume this aluminum is all heated up. All the aluminum is now at 100 degrees Celsius, all 40 grams of it. And here we go, about to put it into water at 1.9 degrees Celsius. And put the top back on. And at this point, we start measuring temperatures every 30 seconds for the next 10 minutes. Okay. Okay, now this is our final experiment of this series. In this one, we're going to take a known quantity of hot water, a known quantity of ice, and a known quantity of water at room temperature and mix them together. The mixture of all of them will eventually have one single temperature, and that temperature is calculatable by figuring out how much heat flows into the ice, out of the hot water, maybe into or out of the tap water, whatever. You should regard calculating the final temperature as a homework problem. What we're going to do right now is just demonstrate how to do the experiment. Now with this one, you have to actually measure the amount of water instead of just using a cup measure. And that's because ice has a slightly different density than water does. So you have to use your spring scale. I've made a little water measuring device out of a cup with a handle made out of a paper clip. And with that, we can measure the amount of tap water going in here. This tap water has been sitting out for a while. So has this, the thermos jar. The thermos jar for this one starts at room temperature. You don't have to cool it down. We'll just assume it's at the same temperature as the tap water. So we're starting off with 40 grams of water at room temperature, and we can measure that with the thermometer. This water is starting out at about 14 degrees Celsius. That's a bit colder than most rooms. Probably has been due to some ice that was in there. But anyway, so this is 40 grams at 14 degrees Celsius. We're adding that to the pot. The amount of ice we're going to add, we also have to measure. Ice is nice in that it's at 0 degrees Celsius. This is 46 grams of ice that we're adding to it. And it goes in there. And we're going to pour out some hot water. This was boiling a few seconds ago. We'll try and add about as much as the tap water. Might as well measure the temperature of that. See how much we have. We have 80 grams of water at 78 degrees Celsius. Put that in there. Now it's all in there. I'm going to put the top on, and we'll measure the temperature again in 10 minutes and see where it has all come down to. We're using the top because until the temperature stabilizes, doesn't really make much sense. We've got ice and water and hot water in there. They all have their own temperatures. Right now, heat is flowing from one to the other. There isn't a well-defined temperature for the mixture, and there won't be until the heat has all settled out. So we're going to give it about 10 minutes for that to happen, and then come back and measure the temperature of the whole thing. Okay, our time is up. We've opened the box, and we can see that the ending temperature of those 3 samples we put together is 12.2 Celsius, and that seems kind of low, but I think the big thing going on here was the ice was melting. Melting ice involves a phase change, and that takes up an awful lot of heat. So It looks like those three numbers are dominated by melting ice, and the bottom line is 12.2. Also, while we were away, it was pointed out to me that when I was measuring those masses, the mass of this measuring cup is quite significant. This measuring cup weighs about 10 grams all by itself, and that obviously has a big effect on a 40-gram sample. So if you're doing the calculation, you have to remember to subtract the mass of the cup when you do your mass measurements before you can calculate the final temperature of the water sample. So that's the last experiment for this round of experiments. I hope you enjoyed them, and write them all up and send me the results. There we go.